Test, test. Test. Let me know if you all can hear me. Go ahead and comment anything in the chat there and let me know if you can hear me, if my voice is okay, or if I need to change anything. What's up, you math nerds? Hope you're having a fabulous afternoon, evening, morning from wherever you're tuning in. My name's Miguel, also known as the Vegan Math Guy, and this is Math Survival Skill Thursday. Also known as the Vegan Math Guy, and this is Math Survival Skill Thursday. What's up, S? Last Tuesday, we were doing some fun Integration B problems, and then today we're just going to do some AP review. Typically, Thursday is always going to be a Math Survival Skill review, and I was asking people as a poll on Instagram what they wanted to review, and it looks like AP Calculus free response questions were the most popular, so that's what we're going to do today. Awesome. Good to hear that my voice is nice and clear. So just as a heads up, I'm just going to go ahead and get rid of this right here. This is the type of problems that we're going to do today. We are going to do some free response questions from some Calc AB practice test. And I'm hoping that you can read this pretty carefully. I'm looking at the screen and it looks pretty good so far. Let me know in the chat if you're taking calculus or AP calculus at that. This will give me a good indicator whether or not we should continue covering this next time or just continue doing some integrals or whatever. How's everyone's day doing? What's going on? What did we do today? Go on a run? Did we go to school? Did we read a good book? Went out on a nice walk? Today, the sun's perfect out here in Washington, and we went out for a nice walk with my dog in between work. So always a good time when the sun is out here in Washington. Anyway, so let's just kind of get started. We have 6 questions that we're going to do. These are AP review questions. I believe the first 2 are a calculator portion. Let me just kind of read this here. Yes, it looks like a graphing calculator is required for these problems. So for the first 2 problems, we are going to be allowed to have a calculator with us. And I'm just going to have a TI-84 with me. You guys can have whatever else you want. Calc 2, all you have to do is integrate. Yes, an AP Calc, I'm hoping that at some point you're going to be doing like series and stuff. That'll be a good time. Anyway, let's go ahead and get started and just read some of the questions here. Hopefully you can read it. It looks like the screen on my end, it looks like you can read it. So anyway, a hot air balloon is launched at time t equals 0. Its altitude in meters is modeled by twice the differentiable function t. And then here we have the table for the first 10 seconds. And this is typical. You are going to have a question like this when it comes to the AP exam. You're probably going to get a table. And let's just read that first question here. It says, from the data shown, let me just go ahead and highlight it actually on my end. It's saying, from the data shown, at what rate is the height changing at 7.5? And this is a very common question that you're going to get. 7.5, we want to find the rate of change at 7.5. And typically a lot of students will say, well, that's the derivative at 7.5. And that's true. However, we only have a table. So what you're going to do is we're just going to estimate on the graph 7.5 or on the table is in between 6 and 9. We have nowhere else to put that in. So if you want to find the rate of change, because it's going to be an estimate, we're just going to find the change between t is equal to 6 and 9. And what that's going to be is just slope. So we're looking for f of 9. Well, I guess I should do h of 9 minus h of 6 over 9 minus 6. Again, this is just an estimate. We know h of 9, if you look at the table, that's 420. Minus h of 6, the table there is going to be 270, so we're subtracting 270 there. Over 9 minus 6, it's going to be 3. You're welcome to use a calculator for this. Whoa, I divided by 50. Oh, there we go. So now we get 50. Now this is the rate of change. So what we're going to say is going to be meters per minute. And one thing to keep in mind is that you are going to get points. If you're taking the AP exam, you're going to get points for showing the work, and you're going to get points for showing the units. So you have to make sure you put units per minute. So Lauren, I'm trying to understand what you're asking and see. Could you explain when you use the approximation thing we learned? Could you use that? So this is the approximation here. All we're doing is approximating the rate of change. I'm assuming maybe what you're talking about approximating is going to be that next question, which is going to be B. So let's go ahead and solve for B there. So we're going to use trapezoidal approximation with 3 subintervals to estimate the average height of the balloon during the first 5 minutes of flight. Okay, here's the thing. A lot of people are going to get confused because they're going to read trapezoidal approximation and they're going to say, okay, I'm going to take the trapezoidal rule, or I'm going to use the trapezoidal rule and be done. But one of the things that they also say is that they want the average height. So what we're trying to do, if we're trying to find average height, this is 1 over, they want the first 5 minutes. So this is going to be 5 minus 0, from 0 to 5 of the function h of t of dt. So average is 1 over b minus a, so we're going to use that equation there. So this is going to simplify to 1/5 integral from 0 to 5 of h of t dt. And typically, if we had the equation for h of t, we can take the integral. That's totally fine. But in this case, we want to approximate, and this is where the trapezoidal rule is going to come in handy. I don't know if you guys remember the trapezoidal rule, but hopefully you do. And I'm just going to write that here. So I'm just going to put trap rule that's equal to b minus a over 2n. And then we have f of a1, or I guess x1, plus 2 times f of x2 plus 2 times f of x3. We don't know how far that's going to go, all the way to the f of n. So if you notice, the pattern here is that the endpoints are not multiplied by 2, but every single other endpoint is. B minus a, those are the intervals, and n is the number of subintervals that we're going to use. Now, this is typically when the table is evenly spaced. And I'm just trying to make sure if that's the case, and it doesn't look like we can do that. I'm just going to kind of graph how the table will look between 0 and 5. At 0, 0, it looks like this. At 2, it's like 280. At 3, it's 330, so it's up here. And then at 5, it's 240, so it kind of goes downward. This is going to be at 240. And what they want is they want the trapezoid. So if we're trying to take the integral of this, it is going to be the area of these trapezoids. Notice that I don't have a trapezoid at the very end because the height of that is just going to be 0. So there's really no trapezoid there. So we're only trying to do the trapezoid of the first two. And we just have to remember the equation for the trapezoid. That's 1/2 base 1 plus base 2 times height. So for the first one, for the first trapezoid, let's call that trap 1. So trap 1 is going to be base 1, which is 1/2 times 280 plus 330 times the height, which is going to be 1, because that's just the distance between 2 and 3. Trapezoid 2, oh my gosh, hold on. Give me 1 second. My iPad just kind of gave out there. So trapezoid 2 is going to be 1/2 330 plus 240, and then times the height, which is a distance between 3 and 5, and that's going to be 2. So we just use a calculator for this. It's allowed for this problem. So for trap 1, we get 605. And then for trap 2, it's going to be 285. So then our area, maybe I can make this a little smaller. If you guys have seen any of my lives before, you'll know that we are always creating more space in the blackboard here so that we can fit as much as we can of our problem. So don't forget that we have 1/5 times and then the estimate of this trapezoid rule, which is going to be 605 plus 285. So we're just going to add those together and then divide by 5, and our answer is 178. That is the estimate. So they just want to do trapezoidal rule. Okay, so the trapezoid part, what we're trying to do is we're trying to assume, again, I graphed it. In this case, I graphed some of the points, and you're just trying to take the area of the trapezoids. And you have to remember the equation of the trapezoid. I'm going to, later on, right now, there's a lot more questions that I want to get through, but I could do a TikTok on the trapezoid rule. I'm going to make a note of that because that seems like something that people get confused on, John. So I'll make sure I do that for you. All right, so that was part B. Now, part C, let's go ahead and read that. It says, during the time from 0 to 10, what is the least number of times that h prime of t must be 0? Now, keep in mind that this function supposedly is continuous. So if we were to graph this at 2, it's 280. So it goes to here. At 3, it's 330. I'm just trying to give you a representation of how this graph looks. At 5, it's 240, so it's down here. At 9, it's 420, so it's further up here. And then at 10, whoops, I erased my graph there. And then at 10, it's 340, so it's just a little bit above. So the function's going to look something like this. Maybe it comes down. Okay? The function's continuous, so I just gave you a representation of how that looks. This is h of t. Now, what they want is they want to ask, when is h prime of t equal to 0? Well, when that happens is when you have a maximum or a minimum. And I'm going to circle them. It looks like there we have a maximum. That's that first maximum that I have around 3, or maybe it's a little bit before or after. And then we have one after 5, and then we have another one possibly at 9 or a little bit after 9. But if you're able to draw this function, because it's going to be continuous, you're going to see that there's going to be at least 3 points where the function is a maximum or a minimum. In other words, where h prime of t is equal to 0. Ivan, the reason why I didn't take the one from 0 to 2 for that one was because at 0, the y value is 0, so the height is 0, meaning that there's really no trapezoid. Here's what I mean. Going back to the graph, so if you were to look at this graph here, I have a height at 2. This is my B1 or my B2. Oh, did I not take it? Ivan, I think you're absolutely right. I can't believe I missed it. Well, but even then, it's not going to, well, it's going to be, the height is 0. You're absolutely right. For that one trapezoid for part B, I should have also included the 1/2 base 1, which is 0, plus base 2, which is 280, and then times the height, which is going to be 2. So you're absolutely right, Ivan. If you're still in the chat, good job looking out. Okay, so that was part C. Just a heads up that, again, we're asking when does h prime of t equal to 0 is asking when we have a maximum or a minimum. I'm going to go ahead and start on D. While we're at it, let me know in the chat. I love to hear where you guys are tuning in from. Where is it that you reside? Where is it that you're watching this live? Right now, I'm in Washington. I'm curious what other people are at. I've seen people from Louisiana. I've seen people in chat from Ohio. Seen people from Barcelona, from El Salvador. I've seen people from Arizona, I believe, Texas. Jace, Washington, represent. Let's go. I'm in Seattle area. Georgia, that's awesome. That's great. California. I used to live in California. I used to live in Orange County. New York, let's go. That's cool. All right, so let's go to part D. I'll continue reading the comments. The more you guys want to let me know where you're tuning in from. So part D is telling that the pressurized propane tank supplies propane to the burner. And then the rate at which the propane is being dispensed is this function here, 8T. So I'm just going to go ahead and call this f of t is equal to 8T e to the negative 0.4t. And this is a rate. And they're saying how many liters of propane are being dispensed in the first 5 minutes. This is beautiful because they give us the function. Oh, OC, let's go. I used to live in Costa Mesa, and I used to live in Irvine as well. So if they're asking how many liters of propane were being dispensed, we're given the rate already. So that's a big clue. Because we're given the rate, we want to take the integral from 0 to 5 of this function. And that's going to tell us the amount of liters that were being dispensed in the first 5 minutes. And here's the thing, you are allowed to use your calculator here. So don't even try to do this on paper. I mean, you're just going to be wasting some time. But I'm going to show you my calculator on the screen so that you can see what I'm going to type. So I'm clicking math 9. My parameters to 5. Oh, that's it, to 8, my bad. And then we're going to go ahead and put the function. So 8x e to the negative 0.4 x. And then notice that I didn't put the variable t. I kept it as x because that's going to be a big issue. If you put t, you're going to get an incorrect answer. You're going to get like an undefined, or it's not going to tell you what it is. And there you go. I press enter, and it gives me my integral, 29.69. 29.69, or we can say that 29.7 liters. I saw in the chat, how do you know when you have to multiply by 1/5? That is a great question. So if we look at part B, they were asking for the average, not just the total height, but they wanted the average. So that's a big clue. When you see average, and they tell you, and I'm sure you're going to see this as you continue reviewing for the AP exam, but when they say average value, not only is it the integral from a to b of the function, but you need to include a 1 over b minus a. So how did I get 1/5 for this particular problem in part B? I did 1 over 5 minus 0. So that's how I got the 1/5. Oh, you know what? You're absolutely right. I have not taken the AP exam since, 16 years ago. I took it in high school. But you're absolutely right. Here they don't tell you what you should simplify to, but someone said, shouldn't you round to 3 decimal places? You know what? I absolutely agree. Going back to D, the more precise you can be, the better. So when we found this integral, we got 29.69970. Now, rounding to 3 decimal places is probably going to be the best method. Actually, I would say just run with that. But one cool thing that you could do is you don't even have to round. You could just truncate it. You can do 699. And if you want to round that to 29.7, I think that's totally fine. But if you were to round, if you were to use the 7 to round, you were going to get a 29.7. So either answer would have been correct. I'm actually just checking on here. It looks like the correct answer, they did 29.7 or 29.6999. I don't think it's going to be a big issue. Awesome, John. Okay, so let's go ahead and go to that second question. Who's taking AP Calculus right now? Or who's just taking Calculus in general? I'm curious to see what everyone's covering and interested in these types of problems. Let's go. Oh, we have an area problem. These are so exciting. Okay, so we had OC, NY, we had California, Georgia, Washington. Let's go. Yes, I love it. Oh, Jace, Jesus. Oh, man, that's unfortunate. In Washington, too. Living here, not proud of that. I'm so sorry. That's great. Yes, that's great that you're learning this now. Obviously, I'm assuming you're going to take the AP exam. I think you should know all this material by, let's see, we're in March. So, like, by April, you should know these things so you can continue reviewing it. And honestly, the best way to review is just to constant practice. Pull out as many practice problems as you can. I'm going to try to go live for AP Calc in general till May, because that's what I did last year, and I think a lot of people found it useful. AP Calc, that's awesome, Ivan. All right, so let's go to part 2 here. They're given the region W in the XY plane. Y1 is the function on top. We have it here. And then y2 is the function on the bottom, which is this cubic function. And then the y-axis is shown on the diagram, so we're good to go. So they want to find the area of W. Who can tell me the first clue? If we're trying to find the area of W, how do we go about it? I'm like always out of breath, and I swear it's the LaCroix that I drink. Integral top minus bottom. Yes, absolutely. Integral top minus bottom. That's exactly what we're going to do. Integral. Owen said integral y1 minus y2. Yes, that's exactly what we're going to do. Because if I draw a strip, I like to call it, on the on the region there, you'll see that I'm just subtracting the top function, which is y1 minus the bottom function. And if I run that strip, if I just continue drawing it, it never changes. The top function and the bottom function is always the same, so I know I'm good to go. I don't have to break it apart into more sections. So all we're going to do is I'm going to set the equation y1, which is my 2 cosine of pi x over 6 minus my x cubed minus 4x squared plus 3x. Notice that I put a parentheses there because I'm subtracting the entire function. Such an algebraic mistake that a lot of us can make. So how do you know which function is on the top? It's y1. Luckily for us, it's labeled. I'm going to highlight that up on top. You see that it's y1, and then that is the function that we have on top. So typically for these problems, they will tell you which one's which. Otherwise, kind of, get a sense for, which one could be, which function is which. So for example, the cubic one has like some nice curves. So that's exactly the one that you're going to have on the bottom there. But again, during the AP exam, they should tell you what it is. Now, what are my parameters? I need my a and b if I'm going to take the definite integral. And if we need to find this, then if you don't have a picture, they should give you functions that you can kind of generalize, and you're able to kind of see which one is which. So that's why I keep, I always emphasize to be familiar with a lot of the graphs. So they'll give you like a sine function or perhaps like a quadratic if they never tell you. Okay, so we can plug it into the calculator. Some people are saying, luckily for us, on the graph here, they kind of tell us the endpoints, or they tell us where it starts. So it starts here at x equals 0, and then it ends at x is equal to 3, which is real nice. All right, and then from there, we're going to go ahead and plug in those parameters, 0 to 3. And now we're just going to plug it into the calculator, okay? Again, this is a calculator portion, so we can do that. I'm going to, again, show you how I'm going to write it out. So we go to math and then 9. Whoops, I already made that mistake. Okay, so we're going to be given that function. This is from 0 to 3. I'm like looking off to the side, so it's kind of hard for me to do this. And then we're going to go ahead and plug in those values. 2 cosine of pi x over 6. And then we're going to close that minus parentheses x cubed minus 4x squared. Got to make sure I write that correctly. Okay, can I just not write everything correctly? Jeez. Okay, so 2 cosine pi x over 6, close that parentheses, minus, and then x cubed, that should be a cube, there you go, minus 4x squared plus 3x. I just want to double check that's correct. So you got to write that down correctly again, and I put my answer there, which is going to be 8.249. 8.249. And I'm just going to truncate it there. I'm not even going to go ahead and estimate that. Okay. Someone just said, just cheat at that point. I mean, you can try, but during the AP exam, you might not be able to. But anyway, one of the things, actually, I'm just going to double check. I might be incorrect. Oh my goodness. Last night I was helping a student out, and look what I did. Huge mistake. Degree F. No. Have to make sure I'm in radian mode. So I'm just going to go ahead and type that in again. There we go, 6.06. I plugged in everything correctly except making sure that I was in radian mode. And that's actually what I was going to mention, but I was completely forgetting about that because I was focused on just writing out the equation correctly on my calculator. So 6.0697. I can truncate that, 6.069, or you can do 6.070 if you wanted to. Awesome. Okay. Just trying to read if there's anything. Now this is, I'm using the TI-84 Plus. Some people might have an old school one. Let me know if you do have one. I can kind of walk you through that, or I can do a video on that later on. But anyway, that's part A. That's how we find the area for that. Now let's talk about part B. So part B is saying, and now you have the horizontal line y is equal to -1, and W is divided into two sections. Sorry, my tripod there was giving out. And write an integral expression for the area on the lower section. So what they want is, if looking at the graph, we have the line y is equal to -1. We want the area of this shaded region there. So how do we go about that? How am I supposed to take the area of that region there? How do I find that region? So one of the things, again, let me go ahead and draw the strip. Oh, -1, So Owen, I see what you're doing. Let me just draw out the strip here. And Owen, I think it might be even a little easier than what you think. Looking at that, if you can see it in blue, all I'm taking is the top function, which is y is equal to -1, and I'm subtracting the bottom function, which is the cubic function there. The only thing that I need to do is I need to know my parameters. So we're going to set up our integral. This is -1 minus x cubed minus 4x cubed plus 3x. And I need to find where these functions intersect. And how do I do that? I'm just going to go ahead and set the equations equal to each other. So I have x cubed minus 4x cubed plus 3x is equal to -1. And now I want to know when this is equal to -1. So you can use your calculator, and I think that's the only way to do that. And again, let me just show you how I'm going to do that. So first, I'm going to go ahead and graph the equation. So x cubed minus 4x squared. I realize on the screen it says 4x cubed. I'll change that in a second. 3x, and then I'm going to graph -1. So I'm going to graph that, and as I'm doing that, I'm just going to erase the 4x cubed, and it's a 4x squared. Yes, thank you, Rafael. Awesome. So if you notice, there's points where they touch. That is this point and that point. So I'm going to be able to find that. Maybe if I can zoom in, but mostly I can just do second, and I want the calculate, and I want a 0. Well, not a 0, actually. So back to my graph. Second, and I want calculate, and I want a point of intersection. And it's going to tell me, give me the function on top. And it looks like I have a point of intersection. That doesn't look right. It's giving me -0.24. So it looks like maybe my window is a little too small. So let me just change it up. Let's do -225, and then let's do -1. No, let's do -3 to 2. This is going to be much better. There you go. So we want this point. We want this point, and we want that point. So once again, go to second calc. I want to go to my intersect. I want this function and that function, and I get a point. X is equal to 1.445, and then I'm going to do it again. Second calc, I want a point of intersect, and now I want to move it closer. As you can see, I'm moving my little cursor. I want to move it closer to the other point. And there I found my point of intersect, which is x is equal to 2.001. So those are my points of intersect. And so now I'm just going to go ahead and plug in those points into my definite integral and do 1.445 to the 2.001 of -1 minus x cubed minus 4x squared plus 3x dx. And Raphael said it was 4x squared, and he was correct. And now again, I'm just going to plug it into the calculator. I go to Math 9. I'm just going to punch it in real quick. 1.445, and then 2.001, and then I put the same thing, -1 minus, and then parentheses, x cubed minus 4x squared plus 3x. And there I get an answer. It's a really small one. Really, really small. Which apparently it doesn't even tell, oh, I don't even think they want you to evaluate. They just want you to write it. That's funny. Okay, so part B over here just says just write it out, which is what we did. So we don't even have to, I didn't even read that. So you would have gotten your points just by writing out the equation. All right, so let's go to part C. So now we want a region R to be the base of a solid S. The cross-section of the solid is perpendicular to the x-axis or squares. Oh my goodness, who is covering cross-sections right now, or who has already covered it? So we're looking at the base is, or the shape is W, so it's that whole thing, and it's perpendicular to the x-axis. So here are my strips. And they're saying that every single time we're doing this, we are creating some sort of squares. So I'm just going to draw two different examples. Okay, every single time, just imagine squares are popping out of here, and we're trying to find the area of these squares. Now, the area of a square is just the side squared. So the area is just the side squared. But the side is the length of each strip. Okay, the side is the length of each strip. So the strip there, we already did it in part A, is just y1 minus y2. Let me erase this real quick so you can see the strips. These are my S's. No matter what the situation is up on the graph, you can see that those are my S's. So I'm going to change this and rewrite it as y1 minus y2 squared. And I'm taking the integral from 0 to 3. That's all we're doing. And so now this is just literally the integral from 0 to 3 of the function 2 cosine pi x over 6 minus x cubed minus 4x squared plus 3x, and then the whole thing squared dx. So you're going to go ahead and plug it into your calculator. Make sure you're in radian mode. Lynette, this is Calc 1, and you can say it's Calc AB. So if you plug it into your calculator, you're going to get an answer of 13.739. Okay, at that point, just plug it into your TI-84 or whichever other equation you might have. That's part C. So now let's go to part D. So part D is telling you that the region W, we're still looking at it, is a top view of an experimental aircraft wing, and the thickness of the wing at any given distance x of y is given by h of x equals 1 minus x to the fourth. So we want to find the volume. Well, remember, if we want to find the volume, what they're trying to say, and this is always like you're going to have questions like this, and part D is always going to be something that's quite like confusing. And I know that they always throw in something like this for part D, and it's always different every year. All right. So if we're looking at this, what they're saying is that you're going to have a shape which has the base here, which is the same strip that we've had. And then we don't know what the shape looks like, but it has like some sort of height. And that height is modeled by this equation, 1 minus x to the fourth, or 1 minus x over 4. So when you find this area, this is y1 minus y2 times the height, 1 minus x over 4. But then you're trying to do this infinitely many times, so that's why you're going to take the integral from 0 to 3 of dx. Okay, and they want us to find the volume. So then it's going to be the integral from 0 to 3 of 2 cosine pi x over 6 minus x cubed minus 4x squared plus 3x times 1 minus x over 4 dx. And again, it's all about just making sure you plug it into your calculator correctly. You can go ahead and do that and practice that on your own if you like. And the answer for this one is going to give you a volume of 3.679. All right. That was part 2. And again, if you're just tuning in, we did the first 2 problems of a free response section of an AP Calc AB exam. I always post these on replays on my YouTube channel, so you're more than welcome to look over them then. And every Tuesday we do integration B, so a lot of integration techniques. On Thursdays we do math survival skills. I think it's going to be dedicated to AP Calc until the AP exam, and then Friday, which is tomorrow, off trail. So anything goes. We'll see what we talk about then. So, Rafael, how do you know how to round? You're going to get your answer, and typically for the AP exam, you want to round to 3 decimal places, or you can just truncate it, meaning just cut off your answer after 3 decimal places. That's typically what happens on the AP exam. But of course, if you're taking this, or if you have an AP class, ask your teacher about that, and see what they can advise. But typically, it's going to be 3 decimal places. Okay, so let's go ahead and go to problem 3. The first 2 were calculator portions. This next one, for the second section, which is so weird, typically it should be 3 and 3, but sometimes they like to cut it off with just 4 problems. And then just keep in mind, this one was you had 6, or you're gonna have 60 minutes to do 4 problems. The first 2 over here, you had 60 minutes, 30 minutes to do 2 problems. So it looks like 15 minutes each. Typically, it's like 3 problems, calculator, 3 problems, no calculator, but sometimes, like in this case, they do 2 calculator portions, and then 4 problems don't allow any calculator. I got these problems online, and I should maybe post them. If you go on my Discord, which is the link in my bio, you'll see the link to that. Go on the calculus channel, and I'll try and put this worksheet on there. It has a bunch of also multiple choice questions that you can look over, and it has an answer key at the end. All right, so let's go to number 3. So a little confusing, or it looks like at first. All right, and they're saying, so you have this tank that has a width of 20 centimeters and is built with a movable partition as shown. So this partition here, so it looks like it's pushing inward, and it's like pushing water out or something, which allows the length SX of a tank to change. Water is being added to the tank at a constant rate of 120 centimeters cubed per second. So hopefully you might be thinking this is not a fluid force, Lynette, but it could just be a related rates. It might be easier than fluid force, so let's not even like get too scared yet. And now they're saying both the length x and the height h of the water are changing with time. So for part A, at the moment when x is 40 and h is 10, x is increasing at 0.1 centimeters per second. At this moment, what is the rate of change of the height changing at that specific time? So it looks like this is definitely a related rates problem. So now what we're going to do is we're going to create an equation for the volume of the amount of water in this box. So the volume at any given time is going to be modeled by 20 times x times h. All I did was take length times width times height. All good, just continue practicing. 73 doesn't mean anything. And because this is a related rates, and because we're trying to find the rate of change of the height, we already know, well, we got to take a derivative of this. So I'm going to go ahead and take the derivative. This is dv over dt. Don't forget this is in terms of time. So now we're going to have 20x times the derivative of h, which is 1. But then you have to multiply by the dh dt. This is the implicit differentiation part of related rates, plus 20 times 1 dx dt times h. Okay, let me simplify this just a little bit. dv dt is equal to 20x dh dt plus 20 dx dt h. And so now what we're going to go ahead and plug in the stuff we do know. dv dt, that's the amount of water that's being pumped into this tank. That's going to be 120. So we're going to put 120 equals 20 times the value of x. They give that to us. They tell us x is equal to 40. So we're going to go ahead and plug that in. dh dt, we don't know what that is. That's actually what we're trying to find because they're asking what is the rate of the height. Plus 20 times dx dt. They tell us right here because x is increasing at 0.1. And then the height, they tell us, is 10. So we're going to plug this in. Unfortunately, no calculators for this. Sophia, why didn't I take the derivative of 20? So the 20, for me, the way I did it was attached to the 20x. So the way I did it when I was looking at this, I was using product rule, where 20x was one function and h was another function. So when I took the derivative of 20x, that just became 20. So think about that for a second. If you have more questions, I'll try to answer them as well. So again, let me go ahead and make this smaller. And remember, no calculators allowed for this. So made it too small. Sorry. So sorry. So let me go ahead and just make this smaller. Here we go. Okay, we still have 120 is equal to 80 dH dt plus, this is where you have to remember some arithmetic skills. If I multiply the 0.1 times 10, that's just 1, right? Or is it 100? Now that'll be divided by, that would just be 1. So 20 times 1, that's just going to be 20. And so now we're going to go ahead and subtract the 20 to the other side. So we get 100 is equal to 80 dH dt. And then divide the 80 to the other side. So we get 100 over 80. And then, by the way, I was looking at this. When I multiplied the 20 times 40, let me highlight that. Someone probably already said it in the chat. No, not yet. That's not 80. That's 800. So instead of 80, I'm going to put 800 there. So 800 dH dt. So back on my problem, I had 100 is equal to 800 dH dt. So I divide the 800 to the other side. So dH dt. So then this is just going to become 1/8 dH dt other side. So dH dt. So then this is just going to become 1/8 dH dt. Now you're going to get your points for putting the correct answer, but you're also going to have to make sure that you include your units, and this is going to be centimeters cubed. And that is the rate at which the height is increasing at a specific time. You're telling me, Lynette, I can't catch my mistakes either. So sometimes I take the chat to kind of look at it. But it's all about just practicing. You got to write it out the way you want to so that it makes sense for you. But typically, if you kind of start off writing the correct equation, take your derivative however you want. This is AP Calc, AB right now. I can do some BC later on, but today I'm just going to focus on AB. Or technically, this is also part of the BC exam because you are going to get questions like this. And so now let's go to part B. So part B, while the tank is being added to the, while water is being added to the tank at a constant rate of 120, a device is introduced which begins to pump water out of the tank. So keep that in mind. This is beautiful. They love these kinds of problems. Something's being pumped into the tank, so that's 120. So I'm just going to put in, that's 120, and out is 15 root T. We don't know what that is. And now they're saying at what time after the device starts working is the volume at the greatest? Well, just kind of think about this. Water is being pumped in, water is being pumped out. And this is a rate. So the rate at which water is there in general is going to be 120 minus 15 root T. Because again, this is a rate. So I'm just going to put water, or I guess I can put W prime, or volume prime, or dV dt. Okay? Because again, this is the water being pumped in at a specific rate and water being pumped out. So I'm putting 120 and I'm subtracting the amount that's being pumped out of it. Now they're saying after what time after the device starts working is the volume at the maximum? Well, that just means maximum, aka the derivative is equal to 0. So we're going to set this equation equal to 0 and move the 15t to the other side. And now I'm going to divide the 15 to the other side. I can't use a calculator, so I'm going to have to use my brain and my basic math skills. I think this divides by 18. Let's see. I'm going to divide it by 3. That becomes a 5. And then this becomes a 40. Yep. So this is 8, not 18. It's going to be 8. So then 8 is equal to root T. Square both sides. And we get that T is equal to 64. And this is going to be 64 seconds. How do I know it was 64 seconds? Look at every single constant or unit here, especially in part B. They're talking about centimeters cubed per second and then 15 root T centimeters cubed per second. So this is going to be 64 seconds. That's part B. So now you kind of should be aware they're going to give you problems like this where something's being pumped in, something's being pumped out. You got to kind of know how to set that up. And again, guys, if you have to leave, don't worry. I always post the replays on YouTube so that you can watch them at any time. So now let's go to part C. So C is saying suppose the pump is starting when the volume is 16,000 centimeters cubed, right? But do not solve an integral expression for the volume of water at the time when the volume is at the maximum. So what that means is you start off with this much plus, now what we're going to find is we're going to find the total amount of water at any given time. And that's from 0 to t. And we're going to take the 120 minus 15 root t. Because what that tells us is we already know that we have this much water being in the beginning, and then this represents the amount of water at any given time, because this, we're taking the amount of water or the rate that it's being pumped minus the rate that it's being pumped out, and then we can take the integral of that. That's a good question. How many points would you get for set up for C? I'm going to assume that's probably just going to be 1 point. Or I'm going to say 2 points, actually. One, can you set this up correctly? So this will be my 1 point. My second point would be if I define this correctly, because you're saying an integral expression for the volume of water at the time when the volume is at the maximum. So the volume is at the maximum is the value that we found in part B, which is 64 seconds. So you're going to have to rewrite this integral and do 16,000 plus 0. And look at my parameters. I'm going to change it to 64. These could be the 2 points that you'll get on here. And it just goes to show if you couldn't get part B correct, then you're going to miss points on part C. So let's just recap real quick. Question 1 was about, understanding area, or can you find the rate of change, and can you kind of graph the function, and can you find the area underneath the curve by approximating areas? The second question is always a region, and perhaps they could even say a volume of a surface, so meaning you have to use a disk or washer method. And now question 3 was all about just integrals. Water is being pumped in, water is being pumped out. So if you can create your equation there, then you will be good to go. Okay, Caden is requesting a velocity function. So what I'm actually going to do, because I am running out of time on my end, unfortunately. I didn't think that I was going to be so into this. But I am going to do one more problem. And what I'm going to do is I'm actually going to post this on my Discord. You can go to the link in my bio. There is a channel for calculus. You go on there, and I'm going to post this here. And you guys could ask questions, copy this. And by the way, the answer key is on this particular PDF, so you can always look back at it. And Kaden was asking for a velocity question. I actually don't have... Oh, this is kind of it. It's a little silly. But you know what? That was the next question, question 4. So we'll just finish this one. All right, so let's go ahead and read this carefully. There's an object along the x-axis, and the graph of the object's velocity is the differentiable function that's given here. Okay, so this is the velocity. Keep this in mind. This is the velocity of the function. In other words, it's the derivative. So there's going to be some questions about that. And then they tell us that region A, B, and C are on the graph, and everything... So they're not going to leave you in the dark here. They're definitely going to tell you some of the points here. But these are pretty obvious that we see the 6 is a 0. The function crosses the x-axis at 10, and then you can kind of see where the minimums and the maximums are going to occur. So that's what they tell you in the very beginning. And now what they want to find is at what point is x the greatest? Now x represents the position, but we're given the velocity here. Okay, so the way we have to work or look at this is we have to think of it in terms of integrals. Okay, so for example, they already tell us the areas, by the way. The first area is going to be 10, the second area is going to be 5, and then the third area is 4. And how did I get those? They were way right here. They tell you that the areas are 10, 5, and 4 respectively. So now they're saying at what point is x the greatest? Now this is velocity, so we can't just look at the function and say, oh, it's going to be at this point and so on. Some people are already saying the answer, but let's go ahead and talk about that, okay? Some people are putting 6, and we'll talk about why that's going to be the case. So if we take the integral from 0 to 6 of this function, which is a velocity function, that's going to tell us the position or how much distance the function had traveled. And that's 10. That's positive 10. And then if you think of it, the area from 6 to 10, although this is 5, the area is below the x-axis, so this is technically negative 5. So just think about what the particle is doing here. It's going 10 in the positive direction, and then it's going backwards 5 units. So then the total distance there is, or the displacement, I'm sorry, is going to be 5. So it went 10 units to the right, and then it went 5 units back. And then what's going to happen with this third area over here, the area is 4, meaning that it went 10 units to the right, 5 units back, and then it went 4 units back again. So that just means that it traveled the most between the first 6 seconds. And that's why Caleb and Samuel were saying that the value is going to be 6. So at what point was it the greatest? It's going to be at 6 because that's the furthest distance that it traveled. Or not x is equal to 6. We're going to say that time is equal to 6. Okay, so now they're going to ask, for how many values of t is the object at position 12? This one's actually really interesting because I don't even know if we can find that value. Okay, one of the things that we should look at in the very beginning, notice that they're saying that at t is equal to 0, the position is 5. So just think of this. We're 5 units here. This is where we start. And in the first 6 seconds, we had talked about the area up on top, which is 10, meaning that you move 10 units. So this is already 15. So at time is equal to 6, we're at position 15. Okay? And now it moved backwards, the next area, which was 5, meaning that it moved backwards 5 units. So at time 10, it's here at position 10. Whoops. And now it moved another 4 units this way. So at time 12, it's at position 14. So they're asking during the intervals for part B, how many values of t is the object at position 12? Well, position 12, I'm just going to draw it out, is here. So there's one point where it crosses at position 12, and then in between time 6 and time 10, it crossed position 12, and in between time 10 and time 12, it crossed 12 again, so it's going to be 3 times. How would you write a sentence explaining this? Is this going to be for part B? Is that what you're referring to? Yes, Kaden, I would 100% agree with you. You're supposed to mention that it starts at 5. So the way you will write it, and maybe I can just like kind of type it out. And this one is kind of silly because you can't really do much math on here for this particular problem, but you can say, so starting at position 5 when t is equal to 0, the particle moves to the right 10 units, meaning it's at position x equals 15, then moves to the left 5, how many units? 5 units, meaning it's at position x equals 10, and then do it again. Then to the right 4 units, meaning it's at position x equals 14. And then you can say this means the particle is at x equals 12 3 times. Now, even in the answer key, you'll see it on the Discord. And Samuel, I think you're right. If you put f is continuous, I think that's going to be fine. Otherwise, it's already stated for us what it's telling us is differentiable. I think the more precise you could be, the better. But if you look at the answer key, that's kind of like the way they wrote it. Okay? Yeah, so I think the fact that it's differentiable. Yeah, so explain your reasoning. That's kind of like the reasoning you have to explain. And even this drawing itself, I believe, would be good. But typically, if you write it in like in a sentence, I think it should be fine. It's so interesting how part of the AP exam, it's not just knowing the material, but also can you explain it in words? Can you use a correct theorem to state that? Okay. So now we're going to talk about part C. Let me go ahead and erase this. So part C, we'll have to erase this here too. So part C is asking, between 9 and 10, is the object increasing or decreasing? Explain your reasoning. Now, the way we know whether the object's speed is increasing or decreasing is by examining the velocity and the acceleration. So if the velocity and acceleration have same sign, then this tells us the speed is increasing. And if the velocity and acceleration have opposite signs, then this means the speed is decreasing. That's one of the important things, and I believe in rectilinear motion, that's exactly what you guys were covering. Okay, so I'm just going to show, yes, some people are doing F minus plus, and let's go ahead and show that. So let's go ahead and examine the velocity between 9 and 10, okay? Now, keep in mind, this is up here, the graph. Let me just put this back for some people that wanted to see it. There we go. Okay, so let's go ahead and examine the velocity. Remember, this is the velocity function already. So between 9 and 10, which is 9 and 10 here, the velocity is negative. It's below the x-axis. So you're going to say on interval 9 through 10, the velocity is less than 0. You can say the velocity is negative if you want to. The acceleration is the slope of velocity. So looking at the graph between 9 and 10, I drew that in blue. The slope is positive. And so on the bottom, we would say the slope is positive. So one's negative, one's positive. And as I mentioned, if they have opposite signs, that means the speed is decreasing. Then we can say because velocity and acceleration have opposite signs, the particle is decreasing. So I'm just going to put decreasing. But again, make sure you write it in your own words. That's the explanation part. I wish I would totally be your personal tutor, but I am all booked. But I'm on here. So on TikTok, go on Discord, post your questions, and then I'll talk about them. I'm going to devote a lot of my Thursdays, the math survival skills on Thursdays, to AP Calc so that students like you can start practicing for that exam. All right, guys. So this is going to be our last problem, D. Let me go ahead and erase this. And of course, don't forget, I'm always on here on Tuesday, Thursdays, and Fridays. And if you want, you can always follow me on TikTok, post your questions there, follow me on Instagram, or you can follow the Discord where there's a bunch of math nerds that love to discuss math with you. So now they're asking during what time intervals is the acceleration positive? So that's kind of just what we were doing. Okay. So we're going to look at the graph. The acceleration is positive, meaning the slope of the velocity. We have the velocity function right in front of us. So we're looking for positive slopes. So if you notice, between 0 and 3, the slope is positive. Between 3 and 8, the slope is negative. So we don't want that. But between 8 and 12, it looks like, the slope is also positive. And that's what the function is going to be decreasing. So the way you can write it is you can say a of t is positive when f, or I guess, did they tell us the function? When v of t has a positive slope. And then we're going to say this occurs on intervals, and you can put 0, 3 and 8, 12, Or you can do 0 is less than t less than 3, or 8 is less than t less than 12. I think that's totally fine. Okay? Either one's going to work. Yeah, so I think you're right. We don't need a graph. Maybe I'm reading the wrong thing. But if you're looking at the graph, am I? Yeah, I'm just sorry, I got confused on my end on what I was looking at here. But it looks like the live is still showing this screen, which is good. So yes, you can say, or you can say this is already f prime or f double prime. You can describe it in so many ways, but for the most part, what they're making sure that you understand is, do you get the gist of finding the acceleration in terms of this graph? So if you can identify, well, this is my velocity function, the acceleration is a slope of these lines, then I'm good to go. There's a lot of different ways that you can write it. The more precise you can be, the better. And of course, free response questions, I mean, they're not many people are gonna get perfect scores. You'd be very surprised. You can struggle with it and still get a 5, or you could think it's extremely easy and not do well just because you didn't write things correctly. So it's all about practice. My best suggestion is to continue doing problems like this. You can look them up online. I have, I believe, another video where I do free response questions on my YouTube, but I am gonna post this replay on my YouTube channel for you to review whenever you like. Anyway, guys, so that was our last problem. There's 2 more on here, but again, I'm going to post it on the Discord, and you're more than welcome to work on those problems. Some people, what they have requested when they want to do these problems on their own is they like to take screenshots of these problems here. So I'm going to move my screen a little bit. This is question 5. If you want, you're more than welcome to take a screenshot of that. Give you 10 seconds to take a screenshot. And Caden, yes, the lives are typically around the same time. So if you're watching it now, about the same time, Tuesdays, Thursdays, and Fridays. John, can you say what MCK is? I'm not sure the abbreviation there. Okay, here is question 6. Let's go ahead and take your screenshot. So John, if you tell me what MCK is, go ahead and give me... Oh, multiple choice. There you go. I can't believe I didn't know that. Yes. I am going to do that. Today I just want to do free response. It looks like that's what most people on Instagram wanted to do, so that's what we're doing. But I do have multiple choice questions that I could do as well. I believe I have a YouTube video from last year covering those things, so look it up, and you'll be able to find it like almost buried in like one of the very beginning videos that I did. MCQ, yes, multiple choice questions. Thank you. Yep, thank you. Anyway, guys, so I'm going to post this on Discord. You guys are welcome to look over it, but I am going to see you all tomorrow, same time. It's going to be off trail, so we're going to cover, I think I kind of want to do some crazy integrals, maybe some double integrals. That'd be kind of fun. But anyway, I hope you guys have a fun rest of your Thursday. If I don't see you tomorrow, have a fun weekend, and I'll see you the next week. Around the same time, John. Same time. So if you're watching me right now, around that time. So 3, my time. All right, everyone. I hope you all have a great day. I'll talk to you soon. See you later.